Good afternoon. Ma'am, we will go for today the Julia arrays. So just we will go for the next concept of this Julia arrays is similar to the our normal Python based vectors and lists. So here we have the arrays in the Julia, and within this we will be go for either creating an array with the same type of elements, or we can go with the different types of elements. And we can also nest the array. That is, one array can be nested into the another array. So we don't have any type restrictions. And we have a one more facilities if you require the typing based on the type. If you want to create an array, we can create the array. Otherwise, we can go for the non-typed arrays, okay, or multiple type of arrays. So whenever we want to create a one-dimensional arrays, we can go for like this. We'll use the square brackets for creating of the array. So within the square brackets, we can mention the elements with a separated by comma or without any separations also we can give. So like we can specify the one space, two space, three, or we can use it as one comma, two comma, three as a one-dimensional array. And if you want to create any undimensional array and uninitialized array, then we can go with the like this. So for that we'll use the array function. Okay, within the array function, we'll specify the data types. So if we want to create an array for a specific data type, we can create the data type and specify the undefined array. That is, we don't want to give the any values. So we want to create an undefined array and with a dimension of 3. So we can create the 3 elements array of type of int64. Okay. So it gives all the elements with the zeros, and this is also not restricted or particular for all the arrays. Okay, sometimes it gives the garbage values and sometimes it gives the zeros for the uninitialized array. Shall we go for next one? This is actually in the previous slide. We are creating a three-dimensional array. So with the three as the number of arrays and 3 rows and 3 columns. That is, each two-dimensional array will be created with a 3 by 3 dimension. So this is also we are creating of a type int64 and as an undefined array. So here it gives the default values is like this. So this is the first array. Here these are the default values, and second array and third array. So it is considering the first two dimensions as the rows and columns, third dimension as the number of arrays. So generally in our C and C++ and Java, we will be consider the first dimension as the number of arrays, second and third as the rows and columns. Okay, but here considers the third as the number of arrays, different arrays, and first and second is the rows and columns. So next is arrays of anything. So you can create an array without specific to the particular data type. You can specify some values as the integer values, some as the float values, or we can include any constants, or we can include the string values. So this is the anonymous array. So whenever we are not specifying any particular variable for the array, then that will be created as the anonymous array. If we are specifying a particular variable, then that will be created as the defined array with a particular variable as the location. So here the elements is 5 elements. So one is the first element, and second, third, and fourth. So pi is actually the constant, which is a predefined constant for our Julia. And tan is actually it is also a constant. Okay, but it uses like a method, and we can specify the required values. So or it gives the total 12 values. That is from the 0 degrees to 360 degrees. And if we have to create an empty array, so we have the two rotations. So one is A equals to, we can give the blank square brackets, that is also creates an empty array. And we can also specify the int64 of square brackets, that is also creates a blank array. So int64 is, it creates an array with of a type int64. Otherwise, if you are creating only the square brackets, okay, that is any type of array. So that can accommodate any type of values. Okay, just we will check the creation of arrays once. So just we'll check the creating of arrays. So marks of a student is equals to. So we want to specify some marks. This is the array for us. So by default, based on the values, consider the array type. Okay, so that there are all the values we are giving it as the integers. So that we can consider it as the A64. Okay, say for example, if I'm specifying a different types, then automatically by default it takes it as the any type of array. So Ramu is the name, and 12.34 is a some value. Okay, then it creates. Yeah, we can combine. So whenever we are combining the values, then it considers the data type of array as the any. If we are not using a different types, then it automatically considers the common type of those all values. Okay. Another empty array is the, say for example, you can create as a empty any type of array as the empty of square brackets. Okay, or you can create a type of array. ARR underscore number is equals to, say for example, int 64 of 2 square brackets. Then it creates an empty array with the type integer. So similarly, we can also create a strings array. Names equals to string type. So it creates a one string array. So these are the different types of array creations. And not only this, we can also have the range functions here in the Julia. So for that, we can create an array like, say for example, array 1. So there is a function is called as a collect. So it takes the 3 parameters. First parameter is the start. Second parameter is the step. Third parameter is the stop. So we can specify the starting value as the 1 and step value is the 2 and ending value is with the 20. Sorry. So it's not the comma, it is a colon. So now it creates an array with the 2 difference. So each and every value, second step, it creates an array. So collect is the function. So here we also have the range function. Both we have collect function and range function. So both we can use here. Say like array 2. That we can specify it as collect of range of function 1, 2, 10. So the range we can use like this. Okay, this range function, it is considering it as the points values. So based on the point difference, it is taking the values. So it is a starting value is 1.0 and the ending value is 10.0. Okay. And 2 is not, it is considering it as the step. So here actually we need to give the step difference as the percentage. Okay, 10 is, it is considering it as a 10 difference, that is 0.10. Number of points difference is the 10. So from 1.0 to 1.1, 1.2, 1.3, that is why it is taking it as the, so 0.1 as the difference. So here the 2, it is not considering it as a 0.2 difference. That is, it is not taking it as, so that we are getting only starting value and ending value. But mostly we need not to use the range. We'll generally go for with the collect only. And there is a one more function is that actually it is not a function. There is an operator which is called as ellipsis operator. So we can specify it as 1:10 and 3 dots. This is called as the ellipsis operator. Ellipsis operator. Okay, consider whenever we are specifying only ellipsis operator after the last element, okay, this generates all the values from the beginning value to the ending value. So here we need not to use the collector function. Okay, without using the collect function, we can create with the ellipsis operator. Okay, by default, we take the step value as the first. Okay, we are not able to have a specify the step operator. And in the similar way, whenever we want to create a multiple dimensions of the arrays, like matrix 1. So for that, we have a two types of a specific creating of a matrices. We can create the matrix with the specific values. Okay, so that is we can do like say for example 1, 2, 3 as a first row, and you can separate the rows with the semicolon. 4, 5, 6 semicolon 7, 8, 9. This is the one way to create the matrix. So we can separate with the semicolon for the values. The comma is the optional. Either we can give the comma, or without the comma also we can give the array. So this is the one way to create the matrix. The another way to create the matrix is using a collect function. We can specify for the 3 times and we can create the array matrix. That is, we can write like collect of one, two, three values, brackets close, semicolon. A similar way, we can give the another collect function for the second row. So this is for the first row. Collect 1, 2, 3. This is the starting value. This is the ending value. And 1 is the step value. So 1, 2, 3 values it generates with the step of 1. So similarly, we can give the collect function for the second row. That is 4 is the starting value. 1 is the step value. 6 is the our ending value. Similarly, we can create the another row. Collect of 7 is the starting value. 1 is the step value. 9 is the ending value. Created as a 9-element vector. Yeah, I'm trying this. That is with the one difference, we can give the 1. Otherwise, if it is a more than one difference, we can give it a more than 1. We got the sorry. Just creating as a 3 element, 3 different vectors. So it has to generate. Okay. So using a collect function, it's not properly taking the values as a 3 rows. So it is just considering it as a 9 elements array. So otherwise we can use the variable different arrays. So we can create the different arrays and we can combine the 3 arrays as a single matrix. So next, the different ways of other ways to create a matrix. So we'll see. Okay, this is the what we have need to create the multiple dimensions array. Select function to create the ellipsis operator, or we can also call it as a splat operator. And using the range function, we can specify the one, the step value, and stop value. So these are the using the comprehensions. How can we create the arrays? Okay, this is also similar to the Python. So we can specify there are the three parts of the collection, the comprehensions. First part is our expression, that is our function. So second is we will start with our control statement. That is generally we will go for the impedance arrays, we will go with the any iterative statement, that is one. And next we will go with the variable, that is whatever the temporary variable which we want to collect the values into that variable. And next is our range of the values. So with this one, it collects the values from the range to the temporary variable, and that temporary variable is substituted within the expression. So for each value of this for loop, okay, that will be substituted into the expression, and that expression result we will get as the element of a array. So here we are not specifying a variable, so that it will be considered as an anonymous array. If we are giving a variable, then it stores the elements into that variable. Okay. So here we are creating an array with the power values power of 2. So n power 2 for all the n values in the 1 by 1 to 10 range. So it takes the 1 by 1 value from the 1 to 10 range and applies the n power 2 and displays the value. So this comprehensions will be executed repeatedly for all the values, whatever we are specifying in the for loop. So generally, our for loop will be work like, so it takes a 1 by 1 value with the range and applies it. Similarly, it also works in the one line statement. Okay, that is for the power, and this is for the table, like products. It takes all the values within the two ranges. It collects the values n from the one range, that is 1 to 10. M is from the other range of 1 to 10. And it creates the array as a 10 by 10 array. So here we are specifying our dimension of the rows and columns. So 10 by 10 array. So it takes the n from the first range and n from the second range. So and apply the substitute that values from the n into m and displace it into the 10 by 10 array. And similarly, we can also use that in a collect function also. So without giving the values, we can use the comprehension in the collect function. Powers equals to so will be created as the cubes. N power 3 for n in 1 to 10 or 1 to 5 or whatever it is. So then it creates a cubes array with the cube of each and every value from the 1 to 10. Table